Hi guys, welcome back to 5 a Day. In today's Redox chemistry, I'm going to talk about balancing half equations. There are basically two methods to balance half equations. Okay, for method 1, first we balance the elements that are reduced or oxidized by calculating the oxidation numbers to check which atom has been oxidized or reduced. And then in step 2, you use electrons to balance the oxidation number of the atom or atoms that were oxidized or reduced. Okay, and when you have done that, step 3, you balance the overall charge on both sides of the equation using H+, if you conduct the reaction in an acidic medium, or you use OH- if the reaction was carried out in a basic medium. And finally, in step 4, balance all the H and O atoms in the equation using H2O. Okay, and in method 2, it's basically the same 4 steps, but only the order differs in method 2. Okay, in step 1, it's still the same. You balance the elements that were reduced or oxidized. Now, if you look at step 2, we add water to balance the O atoms found in the half equation. If you recall, in method 1, we add electrons to balance the oxidation number. So there's a difference here. Okay, after step 2, again, you will add H+ or OH- to balance the H atoms. So depending on the medium that the reaction was carried out. And finally, in step 4, you balance the overall charge of the equation using electrons. Let us look at example 1. We have the manganate ion. The manganate ion is a very strong oxidizing agent that is commonly used in the lab. Okay, in oxidizing the other compounds, it itself will be reduced. So if this reaction was carried out in the acid medium, it will be reduced to Mn2+. So in the first step, before we even balance the manganese ions, the manganese atoms, let us calculate the oxidation state of the manganese atom in the two particles. Okay, if you have done correctly, the oxidation state of manganese inside the manganate ion is +7. And for the Mn2+, it is +2. Okay, on both the left and right hand side of the equation, there is only one manganese atom. So, step 1, balance the atom that has been reduced. In this case, they are both balanced. One manganese on both sides. Okay, step 2, balance the oxidation state by adding electrons. So, for manganese atom, if you want to change the oxidation state from +7 to +2, the manganese atom must accept 5 electrons. So in step 2, we add 5 electrons to the left-hand side. After you add the electrons, in step 3, you have to balance the charges on both sides. If you were to look at the left-hand side, you have 1- from the manganate ion and 5- from the 5 electrons. So altogether, there are 6 negative charge on the left-hand side. And there are 2 positive charge on the right-hand side. So how do I make the charges on both sides equal by adding H+? You do this by adding 8H plus to the 6 negative charge. So overall, on the left-hand side, you will have 2 positive charge. And that will be the same as the right-hand side, also 2 plus. And finally, on the last step, you will add water to balance the H and the O atoms in the equation. So in this case, we add 4 water to the right-hand side so that both sides will contain an equal number of H and O atoms. Okay, did you manage to get the balanced half equation? Okay, let us now move on to example 2. Okay, again another reaction carried out in the acid medium. Okay, here we see the dichromate ion. This is another common oxidizing agent used in the lab. Okay, while it oxidizes others, it itself will be reduced to chromium 3+. Okay, do feel free to pause the video if you would like to try balancing this half equation on your own. Okay, if not, we will carry on. So in our first step, balance the atom that has been oxidized or reduced. So let us do that by calculating the oxidation state of chromium here. If you have done it correctly, the chromium here is +6 in the dichromate ion. It will be reduced to chromium 3+, so the oxidation state will be +3. Okay, if you were to look at the dichromate ion closely, there are 2 chromium atoms inside. So now for step 1, you have to balance the atom that has been oxidized or reduced. So in this case, chromium has been reduced and 2 of it has been reduced. So we add a 2 to the chromium 3+, so that there are 2 chromium atoms on both sides of the equation. Okay, next. Okay, if I were to look at the oxidation state, +6 to +3, each chromium atom must accept 3 electrons to be reduced to the +3 state. Since there are 2 chromium atoms in dichromate, 2 of them must accept a total of 6 electrons for both the chromium atoms to be reduced to Cr3+. So here I add 6 electrons. If you recall, step 3, we have to add H+, since this reaction was carried out in the acidic medium, to balance the charge on both sides. So if you were to calculate the charge, here there's a 2 minus and there's 6 minus here. So overall, it's 8 minus on my left hand side. And 2 3+ ions here. So this is 6+ charge on the right hand side. 8 minus to 6+. So altogether you must add 14 positive charges. So overall on both sides you will have a +6 charge on both my left and right hand side. This is important because this is an equation. So everything on both sides must be balanced. Okay, at the end of it you add water to balance the H+, the H atoms and the O atoms. So if you were to look here, there are 14 H atoms and 7 O atoms. So if I were to add 7 water, all the H and O atoms will be balanced on both sides. So did you manage to get the balanced half equation for dichromate? Okay, Let us now move on to example 3. Again, another reaction carried out in the acid medium. Okay, here we have SO2, a commonly used reducing agent. Okay, reducing others, it itself will be oxidized to sulfate 6. So if we were to calculate the oxidation state of sulfur, plus 4 in sulfur dioxide and plus 6 in sulfate 6. Okay, checking both sides. There is one sulfur atom on both sides. It's the sulfur atom here that is oxidized. So, since there is one sulfur atom on both sides, okay, step 1 is done. Next, let us balance the oxidation number using electrons. From plus 4 to become plus 6, the sulfur atom must give away 2 electrons. So 2 electrons must come out from the sulfur atom to form sulfate 6. So the 2 electrons, yes, you put them on the right hand side because they have been given out. Now going on to step 3. You balance the charge on the left and right hand side using H+, because the reaction was carried out in the acidic medium. So if I were to look at the left hand side, SO2 is a molecule, so there is no charge, 0. On the right hand side, sulfate 6 is 2 minus, and 2 minus for the 2 electrons, so it's 4 minus here. So if I were to plus 4H+, my right hand side will also give an overall neutral charge or 0 charge. So both sides no charge. Lastly, add water to balance the H and O atoms. So how many water molecules did you work out? Okay, yes, it's 2 water molecules, 2H2O on the left hand side, so that on both sides of the equation, the H and the O atoms will be completely balanced. So did you manage to get the right equation again? Okay, if not, let us try out example 4. In this example 4, it's a reaction carried out in the basic medium. Okay, again we look at manganate ion as an oxidizing agent. Okay, as this reaction is held in the basic medium, it will no longer be reduced to Mn2+, but rather, after the reaction, you will get MnO2, which is a brown PPT. So let us start by calculating the oxidation number of the manganese atom. Okay, in the manganate ion, oxidation state of Mn is +7, and in the manganese dioxide, oxidation state of Mn is +4. So for step 1, balance the atom that has been reduced or oxidized. So in this case, if you were to check both sides, Mn, there is one Mn atom on both sides. So step 1 is done. It is balanced. Step 2, balance the oxidation state by adding electrons. So in order for Mn from the +7 oxidation state to finally become +4, it must accept 3 electrons. So we add 3 electrons to the left hand side. Okay, going on to step 3. Since we are carrying out the reaction in a basic medium, we are going to add OH minus to balance the charges. So looking at this equation now, on the left hand side, manganate minus 1, 3 electrons minus 3 charge, and on the right hand side there is no charge. MnO2 has no charge at all. So in this case we have to add 4 OH minus to the right hand side, so that on both sides of the equation there will be 4 negative charge. And finally, you will now add water to balance all the H and O atoms. So we add water to the left hand side so that all the H and O atoms on both sides will now be completely balanced. Okay, did you get the right answer again? Okay, let us now move on. Let us now look at the last example, example 5. Here we have Cl2 being converted to ClO3 minus in an acidic medium. Okay, let us now start by calculating the oxidation state of the chlorine atoms. In Cl2, in the elemental form, oxidation state of Cl is 0. For ClO3 minus, the oxidation state of chlorine is plus 5. So this is a oxidation half equation. Step 1, balance the atom that has been oxidized here, which is chlorine. If you look on the left hand side, there are 2 chlorine atoms. So for the first step, we balance the chlorine atoms by adding a 2 in front of ClO3 minus. So on both sides now, there are 2 chlorine atoms. Step 2. For each chlorine atom to be oxidized to ClO3 minus, each of them must lose 5 electrons. And since there are 2 chlorine atoms, they must lose a total of 10 electrons. So here, I add 10 electrons to the right hand side, as these electrons has been lost. Step 3. Balance the charges on both sides using H plus for an acidic medium. On the left hand side, Cl2, it has no charge, so there is 0 charge. On the right hand side, you have 2 ClO3 minus, so that gives us 2 negative, 2 minus charge, and the 10 electrons, 10 minus. Altogether on the right hand side, there are 12 negative charge. So in this case, acid medium, we will add H plus. So how many do we add? We add 12 H plus to balance the 12 minus charge, negative charge, to finally give an overall of 0 charge on the right hand side as well, so that it now balances the charge on the left hand side. Okay, and finally, we will add water to balance the H and the O atoms. So in this case, we add 6 water molecules to the left hand side, so the H and O atoms are now balanced. So did you manage to get the correct answer for example 5? If not, keep trying. Okay, in my next video, I will be using method 2 to go through a few other examples in balancing half equations again. I thank you for watching this video. If you find it useful, please leave a like and subscribe to my channel. Thank you very much.